Alright guys, so sorry that I'm not there today when we're supposed to be doing this test review. However, I've created these series of videos over these different problems to try to help you the best way that I can. So, I was going to go over problems 1 through 5 first in my first video, and then I'll cover the rest later. So the directions say to solve the following quadratics by one method that we've learned in this topic. That's either factoring, square roots, or quadratic formula. Also, if you hear my dog, I apologize. She's confused as to what I'm doing. So remember, if we are going to use factoring or quadratic formula, the equations must equal 0. So number 1, that's going to be the first thing here. Now, remember, square roots. I can only solve by square roots if there is no bx term. And what I mean by bx term is this term right here, 24x. Because I have the term 24x, I cannot use square roots, and that's how I know I have to get this equal to 0. So the easiest way for me to do this is I'm just going to move everything from this side of the equation over here. Okay, so I'm going to start, and remember this is plus 60, not minus, by subtracting 2x squared from both sides. So that leaves me with 3x squared plus 24x equals 60. And then to get this equal to 0, I'm going to subtract 60 from both sides. And now I have 3x squared plus 24x minus 60 equals 0. And now remember, we look right here, and this number is not 1. So when it's not 1, we look for a GCF. And in this case, the GCF is going to be 3. I have 3, 24, and 60. So remember, we put the GCF out front, open a parenthesis. 3x squared divided by 3 leaves me with just x squared. Want to divide a 3 out of 24. That leaves me with 8x. And then when I divide 3 out of negative 60, that leaves me with negative 20. And that'll equal 0. So now, what's in parentheses looks much easier to factor. So let's go ahead and factor this equation. I'm going to use the box. So remember, we put x squared in the top, we put 8x in the middle, and we put negative 20 on the side. So I have to look at factors of 20, and I'm trying to get them to add or subtract to make 8. So my factors of 20, 1 times 20, 2 times 10, and 4 times 5. Now when I look at these, the ones that can get me to 8 are 2 and 10. So the only way I can make x squared is x times x. It doesn't matter where I put 2 and 10. And then x times 2 is 2x. X times 10 is 10x. And to make positive 8, it has to be a positive 10 and a negative 2. So now, don't forget that I have to put this back in the equation. So I still have my GCF, but now I have my two factors, x plus 10, x minus 2, and that is still equal to 0. So I can use the zero product property, and I'm going to get, first one I get is 3 equals 0, which is nonsense. Having $3 is not the same thing as having $0. And I have x plus 10 equals 0. And x minus 2 equals 0. And when we solve both of these equations, when you subtract 10 from both sides, you'll get that x equals negative 10. And then when I solve this by adding 2, I get that x equals 2. And that is number 1. Now number 2 is slightly different, because notice that bx term is missing. I don't have a plain x. So when that happens, I can solve by square roots. And we solved this one by factoring. You might want to label that. So I'm going to remember, solve my square roots. Our first step is to isolate. So I'm going to get the x squared by itself by adding 22 to both sides. So now I have 25 equals x squared. Step 2 is to take the square root of both sides. So I take the square root. So the square root of x squared is just plain x. And we can't forget the plus or minus sign. So the square root of 25 is plus or minus 5. And then to go one step further, I'm going to break this up so I have two answers. So this means that x equals positive 5 and x equals negative 5. Okay, so not so bad. Step 3. We have to get this in a way that we're used to looking at it. I don't like having the parentheses and this x up front. So let's start by distributing before we decide how to solve this. I have negative 9 equals 6x squared plus 55x. And I have a bx term here. This is my bx term. So because of this, I'm going to factor. So I have to get this equal to 0. And when I do, I get that 0 equals 6x squared plus 55x plus 9. Now, you could use factoring or quadratic formula here. This one happens to be factorable, so that's why we're going to go ahead and factor, and later on it will find one that's not factorable. So, putting this in the box. And the reason why I'm jumping straight to the box is because if I look here, there's not a GCF between 6, 55, and 9. So, finish the box. I have 6x squared, I have plus 55x, and I have plus 9. So remember, when I'm solving these types of problems, I have to list not only the factors of 9, but I have to list the factors of 6. So my factors of 9 are 1 times 9 and 3 times 3. My factors of 6 are 1 times 6 and 2 times 3. And we're looking for 55. So I have to multiply two pretty big numbers to try to get to 55. So my first instinct is to think, okay, well, what happens when I multiply 9 and 6? Because I need a big number to get close to 55. So I'm going to try these. So I'm going to try, I'm going to try using 6 and 1. The only way to make x squared is for it to be x and x. And I'm going to place these so that the 9 gets multiplied by the 6 and the 1 gets multiplied by the 1. So 1x times 1 is 1x. 6x times 4 is good for us because that makes 54x. And I know that if I add both of these, they give me 55. So now I have my factors. I can continue with my equation here. So I'm going to have 0 equals 6x plus 1 and x plus 9. And when I use the zero product property, I get that 6x plus 1 equals 0 and x plus 9 equals 0. And when I solve this, minus 1 on both sides, 6x equals negative 1. Divide by 6, I get that x equals negative 1/6. And over on this side, I'm minus 9 on both sides, and I get x equals negative 9. Okay. Now I'm going to come back up, looking at number 4. So number 4, if you took some time here, and I saw several of you doing this yesterday in class, this one is not factorable. And when that happens, the only option you have is the quadratic formula. So remember, the quadratic formula, you have it on your paper, is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So first thing I have to find here then is what is a, and a is the number in front of x squared, just the number, not the x squared. So a is 9. B is the number in front of the x, not the x, just the number, which is 7. And C is the number in front of the number by itself, which is negative 56. Oh, probably got cut off. There it is, negative 56. So now remember, a good habit to do is to replace all of the numbers or the variables we're going to plug in for with parentheses. And so I'm not doing anything. I'm not changing anything. I'm just replacing with parentheses so I can fill in. So it's negative b, so b is 7, plus or minus the square root of b again, so b squared, 7 squared, minus 4 times a is 9, times c, negative 56, all over 2 times a, which is 9. And this one we are going to get a decimal, guys. So x equals negative times 7 is negative 7, plus or minus the square root of, we should all know that 7 squared is 49. If we type negative 4 times 9 times negative 56 in our calculator, we'll get positive 2016, which is a huge number. All over 2 times 9 is 18. Then I'm going to simplify some more. X equals negative 7 plus or minus the square root of 49 plus 216 is 2065 over 18. I'm going to come up here on the side. And like I said, guys, just get a decimal. Just type this straight in your calculator, plus or minus the square root. The square root of 2065, if we round it, is 45.44. So make sure you're practicing that on your calculator. Divided by 18. And remember, at this point, we make two equations. We have x equals negative 7 plus 45.44 divided by 18. Okay, and when I do that, I'll get x equals negative 7 plus 45.44 is divided by 18. If you type that in your calculator, you should get 2.14. And then we do x equals negative 7 minus 45.44 divided by 18, and that should give you x equals negative 2.91. Okay, so decimals are okay. And then the last problem here, I have no obvious bx term, so we're going to solve this by square roots. Okay, so we're going to isolate. So when I'm isolating, the first thing I have to do is move adding and subtracting. So I'm going to minus 3 from both sides. I'll get 2x minus 5 squared equals 36. Then I have to deal with division, multiplication and division. So I'm going to divide by 2 to isolate what's being squared. X minus 5 squared equals 18, and this is really nice because when everything is being squared on one side, I can take the square root and they cancel. So the square root cancels the square, and I'm left with x minus 5 equals. And 18 is not a perfect square, so sad face. So I have the square root of 18, but we can really quickly simplify that by listing the factors of 18, realizing that 2 times 9 is my largest perfect square partners. So I have x minus 5 equals the square root of 9 times the square root of 2. And then the square root of 9 is 3. So I have x minus 5 equals 3 on the square root of 2. And then don't forget your plus or minus. I just about forgot it. And now we're going to make two equations. I have x minus 5 equals positive 3 on the square root of 2, and x minus 5 equals negative 3 on the square root of 2. And when we add 5 to both sides, we get x equals 5 plus 3 on the square root of 2, and x equals 5